Yeah, in this video, we shall discuss atomic model. We shall look at history of atoms. History of atoms. We shall look at John Dalton atomic model. Then, in the next video, we shall discuss J.J. Thomson atomic model. This will be in the next video. In the next video, we shall discuss Ernest Rutherford atomic model. Then Neil Bohr atomic model. These are the things we shall going to discuss, but in this video, we shall take this first one and this second one. Please, let us move. Let us look at the history of atom. Before I give you the history of atom, what is atomic model? What is atomic model? What is atomic model? Atomic model describes the structure of atoms. Atomic model describes the structure of atom, and it also describes the arrangement of subatomic particles. That is the meaning of what atomic model. It describes the structure of atom. It also describes what we call subatomic particle. Then let's move. What are John Dalton atomic model? John Dalton atomic model. What are John Dalton atomic model? Thank God that you've known the meaning of what atomic model. Atomic model describes the structure of atom. Atomic model describes the arrangement of subatomic particles. Then let us look at what John Dalton atomic model. Or before that, let me quickly explain the history of atom. The history of atom, because I said about history of atom. History of atom. History of atom. Take note of this. The man that first talked about atom is known as Leucippus. Leucippus of Mystos. Leucippus of Mystos. He was a great philosopher. He first talked about what atom, that all matters are made up of what atoms. He talked about atom, but he could not establish atom scientifically. He could not establish what he said scientifically. There was no scientific evidence for that all matters are made up of what? Atom. But the first one that talked about atoms was Leucippus of Mystos. He was a great philosopher. He came from what? Mystos. That was why he is called Leucippus of Mystos. Then Democritus came from Greece. Democritus was a disciple of Leucippus. Democritus gave the first atomic model. It gave the first atomic model. The atoms are made up of what? Tiny, indivisible particles. The first man that gave what? Atomic model was what? Democritus. But Democritus too could not establish that scientifically. Don't forget, Democritus was what? A disciple, a student of what? A student of Leucippus Maestus. Was a student of what? Leucippus Maestus. Take note of that. Democritus was a disciple of Leucippus Maestus. He was the first person that gave what? Atomic model. But he could not establish that scientifically until an English scientist came, which is known as father of atom. Take note of that. Jamb student, take note of that. Waec student, take note of that. Jupeb student, take note of that. The father of atom is known as what? John Dalton. John Dalton. Because he was able to what? Explain that scientifically. John Dalton is known as the father of what? Atom. Father of atom. John Dalton. Let us look at John Dalton. John Dalton atomic model. John Dalton atomic model. Take note, John Dalton atomic model was based on the law of conservation of mass and law of constant composition. Take note of that. John Dalton atomic model was based on what? Law of conservation of mass or law of conservation of matter, any which one. Law of conservation of mass and law of constant composition. Let me write it down. John Dalton atomic model was based on law of conservation of mass and law of constant composition. Take note. These are the two significance of John Dalton atomic model. Then what are John Dalton atomic model? I will give you John Dalton atomic model and give you their limitation. Limitation. Let us look at that. John Dalton atomic model now. The first one, it says that all elements are made up of what? Tiny and indivisible particles. The first John Dalton atomic model. All elements are made up of tiny and indivisible particles called atoms. Take note. That was the first atomic model of John Dalton. All elements are made up of what? Tiny, very tiny, and indivisible particles called atom. Number two, it says atoms can neither be created nor destroyed. He said that atoms can neither be what? Created nor destroyed. Take note. Number three, he said that all atoms of the same element are alike in all aspects, but differ from atoms of other elements. That is the third one. The atoms of the same element are what? Alike in all aspects, but differ from atoms of what? Other elements. For example, when you have chlorine 1735.5, chlorine 1736.5, that is, atoms of the same element are alike in all aspects, but differs from atoms of other elements. But the discovery of what? Isotopes prove this one wrong. The discovery of isotope prove this wrong. I will still give you the limitation to everything. Number four. It says, when atoms combine, they do so in simple ratio. That when atoms combine, they do so in simple ratio. The combination of atoms are in simple ratio. Combination of atoms are in what? Simple ratio. Until this one, I will give you what? Prove that one wrong. I will give you all the limitation. Number 5. Chemical changes is as a result of combination and separation of atoms. That means for you to have a chemical change is as a result of what? Combination and what? Or separation of atoms. The separation of atoms or combination of atoms will bring about what? Chemical change. For chemical change to occur, atoms must combine or separate. These are what? The 5 what? Atomic model. The atomic model of John Dalton. And take note, there was a question that came out in UTME 2002. The question says, which of the following atomic model of John Dalton is still valid? The one that is still valid. The one that is still valid is what? Atoms can neither be created nor destroyed. Take note of this, I will explain. This one is still valid to some extent, that atoms can be created nor destroyed. Is still valid to some extent. That question came out in UTME 2002. Take note of that. Which of the following atomic model of John Dalton is still valid? The one that is still valid to some extent is what? Atom can neither be created nor destroyed. Then let us go to the limitation of all this. Limitation. Please pause the video, write it down. Please pause the video, write it down before we go to limitation. Pause the video and write it down. Okay, let's move, class. Yes. Please don't forget to subscribe to our YouTube channel, Neo-TISA School, the best online lecture in West Africa and Africa as a whole. We give you the concept, we give you everything. Subscribe to our YouTube channel, press the subscribe button, comment, like, and share with your friend. Please, you can call our number. I will still put the number on the wall, on the top corner of the wall. That is the number. Please call any one of the number for physical class if you need. Then don't forget to comment on our YouTube channel, share with your friend, like, and subscribe. Press the subscribe button. Let us look at the limitation. The first one, don't forget, the first one says all elements contain what? Or is made up of tiny and indivisible particles called atom. That atom is what? Very tiny and indivisible particle. That an atom is what? Tiny and indivisible particle. That one has been proved wrong. What proved that one wrong? Discovery of subatomic particle. Subatomic what? Particle. The discovery of subatomic particle. Discovery of subatomic particle. Prove that first one wrong. The atom is tiny and is what? Indivisible. That all elements are made up of what? Tiny and indivisible particle called atom. This discovery of what? Subatomic particles such as electron, proton. Prove that wrong. Take note. Number two, that atoms can neither be created nor destroyed. What proved that wrong is what? Nuclear what? Fission and nuclear fusion reaction. In nuclear fission and nuclear fusion, atoms can be what? Created. Even though atom cannot be what? Destroyed. But atoms can be what? Created. Then, but it cannot be destroyed. It can be converted to what? Energy. Take note. During nuclear fission and nuclear fusion, atoms can be created, but it cannot be destroyed. It can be converted to what? Energy. Atoms can be converted to energy. That is why that one is still valid to some extent. According to the UTME 2002 question, it's still valid to some extent. Atoms can be what? Created, but it cannot be what? Destroyed. It can only be converted to what? Energy. In nuclear fission and nuclear fusion, atoms can be created, but it cannot be destroyed. It can only be converted to what? Energy. That means the second one is still valid to some extent. But atoms can be what? Created under nuclear fission and what? Nuclear fusion. Then the third one. What is the third one? The third one says atoms of the same element are alike in all aspects, but differ from atoms of other elements. What proved that wrong is what? Discovery of allotrope. Discovery of isotope. Discovery of isotopes and isobars. Discovery of isotopes and isobars. Prove that wrong. If you want to know more of isotope and isobar, I've done a video on that. Please, you can search for it. Isotope, isobar from Neo-TISA school. You will see it there. The meaning of isotopes and what? Isobar. Prove the third one wrong. Prove the third word, atomic model of John Dalton wrong. Number 4, that when atoms react, they do so when they combine. They do so in simple what? Ratio. That when atoms combine, they do so in simple ratio. What proved that one wrong is what? In some organic compound, such as what? Complex organic, such as complex organic compound, such as complex organic what? Compound. In some organic compounds, such as complex organic compound. And this one, they do not combine. They do not react in simple ratio. That means in some complex organic compound, some complex organic compound do not, let me put it like that. Please let me put it like that. Some complex organic compound, such as starch. Example, sucrose do not react or combine in simple ratio. Take note of that. In simple what? Ratio. Take note of that. Complex organic compounds such as starch do not react or combine in simple ratio. Take note of that. Number 5, the fifth one, that chemical change is as a result of combination and separation of atoms. What proved that wrong is discovery of allotropes. Discovery of allotropes. Discovery of allotropes proved that wrong. Take note of that. These are the limitations to what? To those 5 atomic models of John Dalton. This first one proved the first one wrong. Second one proved that second one. The third limitation proved the third atomic model wrong. The fourth limitation proved that fourth atomic model wrong. The fifth limitation proved the fifth atomic model wrong. Please take note of this. In the next video, we look at our J.J. Thomson atomic model. May God bless you. I remain myself, Jamb.